In this video, I will update my example to use the newer version of the observer pattern in Java. This one uses a class called PropertyChangeSupport instead of the abstract subject superclass. In the previous video, I introduced a few problems with the original structure of the pattern. Let's just recap these and then discuss how the PropertyChangeSupport aims to fix the problems. First, the pattern uses inheritance. Here is the diagram once again, and for the concrete subject to become a subject, it has to extend the abstract subject class. In Java and other languages, you are limited to only one superclass. When my concrete subject extends the subject, it cannot extend any other class. Second, distinguishing events. If the subject can notify about various types of events, or if a listener is subscribed to multiple events, the listener may not be able to differentiate between the events if we only send the data as an object. I previously fixed this by wrapping the data in a container, which also carried the event type. We will see this idea again later. Third, mass notification. The notify listeners method will call all listeners, whether a particular listener is interested in the event or not. This is a problem if the concrete subject can emit different types of events. For my example with the weather sensor, we could assume the sensor could notify about temperature, humidity, wind speed, and wind direction. Some listeners are interested in some events, while other listeners care about other events, but they are always notified about each event. This is both a waste of resources, and the listeners have to do some filtering to ignore unwanted events. Fourth, the single method. A concrete listener becomes a listener by implementing the listener interface. That results in overriding a single method, and therefore all events from all subjects are handled in this single method. In the previous video, I then had a switch statement to figure out which event is received and then what to do about it. Every new event to be handled required updating this single method by adding another case to the switch. I'm not a fan of having to touch existing code to add new functionality if it can be avoided. Okay, now let's look at this other approach, which aims to improve upon things. We use the existing PropertyChangeSupport class in Java. First, we shall update the class diagram. With the current approach, the concrete subject inherits from the subject. But now we follow the principle of composition over inheritance. The PropertyChangeSupport is a helper class to be used by my concrete subject. I will remove the abstract subject, there is no inheritance anymore, and I will make my concrete subject associate the PropertyChangeSupport. Then, instead of my own custom listener interface, we must use the PropertyChangeListener interface. This interface defines a method called PropertyChange. The parameter is an object of type PropertyChangeEvent, which serves a purpose similar to the subject event I introduced earlier to pack both event type and data into one container. The PropertyChangeEvent contains event name, the old value, the new value, the concrete subject, and probably some other stuff we are less interested in. Now, the PropertyChangeSupport, instead of just containing a single list of listeners, it contains a map, with the key being the event name and the value being a list of listeners. We don't have to care too much about the internals of the PropertyChangeSupport, and if you don't know what a map is, just imagine that instead of a single list of listeners, there are multiple lists, one list for each event type. This allows us to add a listener to the list of a specific event it is interested in. I will show it in action shortly. What we have now is actually less of an observer pattern and more of a publisher-subscriber pattern. And there are similarities to the mediator pattern as well. It's beginning to get a bit muddy, so let's not get derailed here. We have the updated pattern in place now. I just want to update the example a bit as well to better illustrate this newfound power. My sensor is now a very smart sensor, being able to measure many things. It measures temperature, humidity, wind speed, and wind direction. Whenever one of these sensors measures a new value, an appropriate event is fired. Interested parties can subscribe to one or more specific events, or simply all events if they want to. Okay, that's the theory. Let's now apply it in code. I have updated the example code as well. Let's just get an overview. The weather sensor first. We can see 4 methods here. When one is called, it will generate new data, and for now just print it out. So there's a method for temperature, one for humidity. Here's the wind speed, and the last for wind direction. The listeners are the same as our original starting point, so I will skip these. And then the class for running the application. First, the UI is created. I have the other two listeners, though not yet being used. Then the weather sensor. And here I used the same helper method 4 times. I am passing in the weather sensor's 4 update methods using the method reference syntax. It is not too important if you understand this. The second argument is the wait time between each update. The method will start a new thread with an infinite while loop. Here I basically call the method which was passed in, so that is update temperature or update humidity and so on. Then there is the sleep for some duration. This is just to get things started, not really the focus, so don't worry too much about this. Instead, let's apply this new version of the pattern. First, I update the subject, that's the weather sensor class. It needs a field of this PropertyChangeSupport class. The argument to the constructor is the concrete subject, so this. Just in case some listener needs to get something extra from this class, or maybe to remove itself as a listener if necessary. I create a method to add a new listener. I must declare a parameter for the event name, that's a string, and then the second parameter is the property change listener. In the body, I will add the listener to the property change support, like this. This will allow classes to register themselves to specific event types. I also need an add method for adding a listener to all events. That looks similar, just without the event name. This will cause the listener to be notified about all events rather than specific ones. And then to mirror this, I need 2 remove methods, one for a specific event and one for all events. Next, I must fire the events. I will start with the update temperature. Here I use the support object and call the fire property change method. There are several overloads. I will just show one. It takes as arguments the event name, for example temperature, and the old value, which I don't have here, so I will just pass in null. That's okay. And the new value, which is the temperature integer just above. The fire property change method actually only notifies if the old and new values are different, which they are in my case here. And the method notifies both the listeners subscribed to this particular event and the listeners subscribed to all events. Let me then update the humidity method in a similar manner, and the wind speed, and finally the wind direction. Now my subject can fire different specific events when specific things change. Then let's fix a listener, the UI class first. It must implement the interface, PropertyChangeListener. This means I must override the method. You can see here the method receives a PropertyChangeEvent object. This is similar to my subject event from the previous video, as I have mentioned. From this object I can extract various information like the event name, the new and old values, and the concrete subject, should I wish to do so. I will just get the new value, cast it to an int, and then convert it to a string and call the setText method. I don't need to do any event type filtering here because this listener will only be subscribed to events about the temperature being updated. Next, the temperature alert. It is done in a similar manner. Implement the interface, override the method, cast the new value to an int, and call the receive sensor data method. And finally the sensor log class. This will be interested in all events, but each event is handled differently. So, as we have seen before, one method handles multiple types of events and must therefore switch on the event type. Out of the 4 problems mentioned at the beginning, we still have not solved this one, where one method handles all events and must be updated each time a new event must be handled. It will be solved in the next video though. Okay, now I just need to tie everything together by adding the listeners to the sensor class. As usual, I do that outside in my start method. I simply add each listener to the weather sensor class and try to remember what I named the events. So another minor inconvenience here, event names are just strings. It is easy to misspell. Or if I update the name of an event, it may not be easy to find all the other places, which must be updated as well, so the event name matches again. There are ways around this. For example, declare the names in a class as public static final values and let all classes reference these string fields. I will leave this fixed to you, I think. Finally, let's run it and see what happens. And it appears that everything works as expected. So thank you for watching.